Today I'm going to do a quick tutorial on how to turn H2O ice to steam. So we're going to start out with an example problem. It says your day starts with a 394 gram block of ice at the initial temperature of 260 Kelvin. You want to convert it to steam at the final temperature at 376 Kelvin. So what we're going to do, I already have my initial temperature, which is 260 degrees Kelvin. I have my final temperature, 376 degrees Kelvin, and my block of ice, which is 394 grams. So our first step is going to be to heat up the ice to 273 degrees Kelvin from 260, because this is our initial temperature right here, and 273 is the temperature of freezing water or ice. And this is not something I calculated, this is just what Kelvin freezes at. Well, the degrees in Kelvin when water freezes. So, to calculate this first step, what we're going to use is Q equals MC, change in temperature. This formula is from my list. It is Q is heat energy, M is mass, C is specific heat, and triangle T is the change in temperature. So we're going to take the mass, which is 394 grams, and my specific heat, which is going to be 0.5. And this number is again just from a list. It's not something I calculated. Since we're working with solid H2O, ice, it is 0.5. That's its specific heat, which is basically just the amount of energy required to raise the temperature per unit of mass. So we're taking that and timesing it by that. And then now we need the change in temperature. And this is simply this minus this. So just to write everything out, we get 13. Now we're just going to simply times it all together. 394 times 0.5 times 13. And if you can see that, it is 2,561. For our second step, what we're going to do is use a different formula. It is Q equals mass times, it's mass times the change in heat of fusion. And that is something, again, that we are just given. That's not something we have to calculate. So what my formula is going to look like is the block of ice. And then we just look at, for fusion of H2O, it's going to be 80 calories. So we're just going to times it by that. And then again, 394 times 80. And we get 31,520. For our next step, what we need to do is raise the temperature of, we have our water at 273 and we need to make it boiling. So what we are going to do is use this top formula again, this one right here, which is going to say mass times our specific heat, which now we were using ice here, and that's why it was 0.5. Now we're using liquid, which is 1.0. So 1.0 calories times, which is just 373 minus 273. Obviously, it's just 100. And if we times that all together, I guess I'm just going to skip ahead. I already know what this is. So that's just all of this times together. For our next step, we need to convert this temperature water into steam, and so this is a state change. So we are going to use this formula right here. So we, again, just our mass of our ice times the latent heat, which is, for this one, we are now using evaporation, sorry. And we are given that it is 539. So we're just going to go ahead and times those together. And our answer is, so this is our last step. And all we have to do is convert, so we have our steam now. We went all the way from our block of ice. We've changed the temperature of it right here. We converted it from ice to water. We went from water to boiling water to steam. And now we just have to change the temperature of it because our final temperature here says 376 Kelvin. So that's what we are going for. So again, for the last formula you have to use for this, it's mass times specific heat and change in temperature. It's just this right here. We're going to do our block of ice, remember, is just this. And now, so our specific heat, because it is steam, is changed, and we know just from looking off of a list, it is 0.484. And then we just need the change from this temperature to this temperature, which is obviously just 3 degrees. So you're going to multiply all of that together, and your amount is 572.88. No, 0.088. Okay. So now that we've done all of these steps, we have our steam at our final temperature. We have everything we need. All we have to do is we need to add all of these together. You're just taking everything you just did, all of this work, to get your final answer. So you're going to add these all together. I guess if you want to see that out, we have that is a 9. $72. Okay. Which at your final amount, which is going to be kind of a large number, it is 286,419.088. So this is the total amount of energy required. So I hope this helps and answers your questions. This is the way that I found that it was easiest for me.